Today, I will talk on rehabilitation of a residential building which is about 92 years old. It is owned by a middle class family. It was constructed in the year 1932 as a single-storied building with the foundation for a provision of three-storied. Later, extensions were made on need basis in the year 1934, 1973 and 1984 in phases. The building stands as it is now three-storied. The location of the site is in the heart of a 525-year-old town Howrah in the eastern part of India. It was once a renowned industrial hub during colonial era. This building is adjacent to a deep pond as it is seen in the Google Earth image and photosnap. The staircase unit, primarily masonry in structure, is on the edge of the pond profile, as you see from the drawing. A vertical crack was noticed right from the ground to the third floor level. The wall apparently showed an indication to incline towards the pond and get detached from the main building. It is scary. It is prudent to mention in the context that the crack was more visible in the last 5 years. Eventually, it has also been noticed that the water level in the summer season has drastically lowered in the last 5 years. It can be correlated in this context that the resisting pressure which the water was exerting on the wall has been decreasing gradually. It might have accelerated the possibility of this wall to get detached from the main building. The condition of the structural components was not at all satisfactory. Corroded structural members were noticed everywhere. The steps and its supporting units were beyond repair. The challenge is how to stop its inclination tendency and restore to its current position, if not to its original position. There are some traditional technical solutions, but all are not practical, considering its restoration to be made by a middle-income family where limited budget is a major factor. The most common method which came first in mind was sheet piling from outside to prevent outward movement of this wall. To do so, a substantial part of the working area was required from the pond side. Unfortunately, the access to the site and approach area to drive the sheet pile would be through others' property and getting permission was unlikely. This option to initiate from outside was ruled out, so the only option left was to do whatever to be done from inside only. It was then conceptualized to pull the wall from inside by network of permanent tie members, anchor the wall with the ground level at the base and tie it with floor levels. A pile was needed to be driven inside the building then. This task is most challenging. The clear space between available for maneuvering was just about 1.5 meter between the walls. Traditional board pile was not expected to be executed as the headroom of the area is only 3 meters. Screw pile or auger pile could not be driven as the space was not enough to handle the rotary unit. Driven pile was beyond practicality due to space constraint both vertically and horizontally. Then what? Here comes in the innovation in thought, clubbed with traditional application. A primitive method of dug well construction was thought about, which was ultimately constructed. Its depth was 3 meter, clearings each of 200 millimeter high and diameter ranging from 0.6, 0.75 to 0.9 meter were installed. The inside ring of 0.6 meter was extended to the ground level. The earth within the well was excavated manually as if a well was dug out. The inner annular ring acted as a shuttering of the pile, making the pile diameter as 0.6 meter. Lesser die rings were not found suitable from workability point of view. It was then dewatered by portable pump and reinforcement cage was inserted to cast the pile. The annular space between the bigger pile and the smaller pile was backfilled with the excavated earth. The remaining spoil excavated earth was later used for plantation after its soil improvement. The reinforced pile cap beam was constructed. The vulnerable wall was then tied with the pile cap through RCC beams to ensure its stability and retainment against future vulnerability. During this whole operation, the wall was temporarily caged by steel members and tied with the existing first floor. Requirement of this safety precaution was obvious. It was a difficult task to align the temporary ties without disturbing the existing walls. Later, long-rooted trees were planted along the bank of the pond, which acted as a natural sheet piling to provide additional safety against sliding and slope failure. Also, this plantation, though small in scale and effect, promotes environmental compliance, which is today's need towards sustainability goals. This renovation work at an individual level, I repeat, individual level, silently but definitely demonstrated the application of traditional primitive approach towards a technical and sustainable solution. I think it deserves salute from engineering fraternity. Some experts define this as an innovative approach. I doubt. Is it really so? In most cases, traditional solutions are all available around us. We just need to pick the appropriate ones and customize during applications. Are we unconsciously biased to use this jargon innovation? I am still searching for it and yet to get this answer. I end this video by extending my thanks to those of our ancestors who developed this dug well in 6000 BC, and it is still in application in different forms and aspects of engineering. Thank you.